Hello guys, welcome back again to my channel. In our lesson today, we are considering number-based system, okay? And in today's tutorial, we are considering the conversion of numbers from order basis to base 10. So, but before we do that, let's understand what number basis is. All right, so this is a system of counting numbers in groups or in bundles. Every calculations or operations we do that involves digits of the number daily is in base 10. You buy something, you want to calculate how much you spent, how much you have remaining. That is in base 10. Now, aside base 10, mathematics operation or numerical operations can still be operated in other bases, okay? Remember that number base is a system of counting in bundles. I can decide to count in bundles of 5. And if I am counting in bundles of 5, that means I am operating digits of numbers from 0 to 4. It must not exceed 4. So we have a bundle of number that will not exceed 4. Then if I am operating in base 10, we are looking at a bundle of numbers that will run from 0 to what? 9. They must not exceed 9. And every base 10 number, every normal calculation you are doing has an equivalence in other bases. Okay, looking at this place, you can see that we have different bases. All right, so aside base 10, we can operate digits of the numbers using other bases. Okay, so what we want to do first is conversion from other bases to base 10. After we have done this, we also consider conversion of decimal numbers. When the numbers have decimal, how do we operate it? We'll look at that too. Then subsequently, we'll now look at conversion from one base to other bases other than 10. We have base 2. We can convert from base 2 to base 5. But in this lesson now, we are considering conversion to base 10. So we'll be considering to other bases. We also consider conversion from base 10 to other bases. It's a full lesson. So one video may not take it all. After this video, I will still do another video to accommodate all of these things. And lastly, we shall also consider operations involving number-based system, where we have to add two numbers in a particular base. We can add a number in base 5. We can add a number in base 2, in base 3, and other bases. So make sure you subscribe to my YouTube channel so that subsequently, when I drop my useful mathematics tutorials, you will be notified and then you'll be able to see the video. So let's go into the lesson. So we are going to be considering how to convert numbers from other bases to what? Base 10. So let's start with number 1. The first thing we do is to expand using the base. What does that mean? Use 2 to multiply all the numbers here. That is 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2. So I've used 2 to multiply all these digits. Then the next thing is to assign indices, okay, from 0 to wherever we stop on the top of 2. That is 0, 1, 2, 3, and 4. Having assigned indices, let us expand. 2 raised to the power 4 is 16. 16 times 1, 16. 2 raised to the power 3 is 8. 8 times 0, that is 0. 2 raised to the power 4 is 2 raised to the power 2 is 4. 4 times 1, we have 4. 2 raised to the power 1 is 2. 2 times 1, that is 2. 2 raised to the power 0 is 1. Any number to the power of 0 is 1. So 1 times 1, we have 1. So let us add all the numbers. 4 plus 16 is 20. And here we have 23. And that is now in base what? In base 10. So we have succeeded to convert this number to base 10. Let's consider the second one. I have 3, 4, 2, and in base 5. So the first thing we do is to expand it completely. That means we have 3 times 5 plus 4 times 5 plus 2 times 5. Then assign your indices, or you call it your powers, 1 and 2. Now 5 raised to the power of 2 is 25. 25 times 3 will give us what? 75. 5 raised to the power 1 is 5. 5 times 4, we have 20. 5 power 0 is 1. 1 times 2 we have 2. So let us add. If you add there, you have 95 plus this, that is 97. We have 97, and that has become base 10 number. Okay, so we have moved this guy. So this number now is equivalent to 97, but 97 is a base 10 number. 342 is a base 5 number. They are equivalent. Let's solve the third one. So we have 6213 in base 8. So let's expand. 6 times 8 plus 2 times 8 plus 1 times 8 plus 3 times 8. Then assign your exponents, or you call it your indices or your powers. Remember that you are assigning the powers to your base. Our base is 8. Now, 8 raised to the power of 3. That will give me 512. Multiply it against 6. We have 3072 plus 8 raised to the power 2 is 64. Then 64 times 2, that will give us 128. Then 8 raised to the power 1 is 8. 8 times 1, 8. 8 raised to the power 0 is 1. 1 times 3, we have 3. So let's add all these numbers. So this is plus 3072 plus 128 plus 8 and plus 3. So we now have 3, 3, 3, and 9 in base 10. So we have also converted this one to base 10. Now let's look at this situation. We have letters, that is English alphabets, mixed up with numbers. So let's see how we convert this one. All right, let's solve number 4. So you discover that this is a base 16 number, and base 16 numbers run from 0 to what? 15. But we don't write from 10 to 15. We cannot write from 10 to 15. We use English letters to represent numbers from 10 to 15. So we have our A to represent 10. We have our B to represent 11. C represents 12. D represents 13. E represents 14, and then F represents 15. So anywhere you see letters, you substitute with the values of each of them. So let's now expand with 16. So the first one will have 16, 4 times 16 plus C. Instead of writing C times 16, you now write the value of C, which is 12. So we have 12 times what? 16 plus, this is 6 times 16 plus E is what? 14. 14 times 16. So assign your indices from 0 to the last number. And this is 3. Let's expand. 16 raised to the power of 3. That's giving me 4096 times 4. We have 16,384 plus 16 raised to the power of 2. That is 256 times 12. We have 3072 plus 16 power 1 is 16. 16 times 6, that is 96. 16 power 0 is 1. 1 times 14, we have 14. So let's add all the numbers now. Plus 16,384 plus 96 plus 14. So everything is giving me 19,566 and in base 10. So we have converted the 16 base to what? A 10 base. All right, so let me choose one more and do, then I'll leave others to you for your assignment. So I've done this first 4, and then let me pick any other one. Let me take H. All right, so I have 7, C, D, and F in base 16. So we expand. This is 7 times 16 plus, what's the value of C? 12. 12 times 16. D, the value of D is 13. 13 times 16 plus, and lastly F is what? 15. 15 times 16. So let us assign the indices. So we have 0, 1, 2, and what? 3. So we now take the powers. 16 raised to the power of 3 will give us 1496 times 7. Times 7, we have 28,672. Then 16 squared here will give us 256. Then 256 times 12. We have plus 3072 plus 16 power 1 is 16, then times 13. So 13 times 16 is giving us 208 plus 16 power 0 is 1. 1 times 15, we have 15. Let's add all the numbers. Plus 28672, then plus okay, plus 15, then plus 3072. We have 31967 in base what? In base 10. So we have also successfully converted that to base 10. So you solve this 3 and this one. You can drop your answer in the comment section or look for my phone number anywhere around this video and send it to my WhatsApp. Thank you so much for paying attention. Please do it to like this video, share it to your friends, and follow for more interesting mathematics tutorial. Catch you up in my next video. Bye. All right, let's continue with the lesson. We have decimal numbers and we are asked to convert it to what? To base 10. So we are going to be looking at how we perform this operation. So starting from the first one, 101.10101 in base 2. So to convert it, we expand first. 1 times 2 plus 0 times 2 plus 1 times 2. Plus, I want to use this plus to show demarcation between the decimal part and the whole number part, but it's still the same thing as this plus. So we have 1 times 2 plus 0 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. So I have expanded all these guys using the base 2. Let's assign indices. Whenever you want to assign your indices, you are starting from the decimal number, from the decimal point, okay? Go to the left first. This is 0, 1, and 2. Then continue to this part. But this time around, you are adding a -1, -2, -3, because we have moved over to the decimal part. Decimal means a denominator of 10. So by adding -1, this guy becomes a denominator. -2, -3, -4, and then -5. So the same way you added 0, 1, 2, here you are adding -1, -2 until the end. So let's expand. 2 power 2 is 4 times 1, we have 4. 2 power 1 is 2 times 0, we have 0. 2 power 0 is 1. 1 times 1, we have 1. Then plus, I may not need to put this kind again. Now, 2 inverse means 1 over 2. 1 over 2. Anytime you have inverse, that is just power minus 1, you have to put 1 over the number you have there. Let's assume you have x inverse. This is same as 1 over x, right? So 1 over 2 times 1 will give me 1 over 2. Then over here, I'm going to have 1 over 4. Reason is because 2 raised to power 2 is 4. Now because of the negative, we have 1 over 4. So 1 over 4 times 0, that would give me 0. Then 2 raised to power minus 3. Now 2 raised to power 3 will give us 8. Because of negative, we are going to have 1 over 8. Then 1 over 8 times 1, 1 over 8. Okay, then lastly, okay, not lastly, 2 raised to power 4 is 16. Now because of the negative, we have minus 16. Sorry, 1 over 16. Then multiply it against 0, we have 0. Plus 2 raised to power 5 is 32. Because of the negative, we have 1 over 32. Then 1 over 32 times 1, we have 1 over 32. 1 over 32. Okay, so let me take out this so that we don't get confused. So let's simplify. 4 plus 1 will give us 5. So write 5 plus. Then over here, we have 1 over 2 plus 1 over 8 plus 1 over 32. Now, how do you simplify fractions? The normal way you solve fraction, that is how you want to simplify this, okay? So we have 5 plus LCM of 32, 8 and 2 is 32. So I'm going to take 32, common denominator. 32 divided by 2 will give me 16. 16 times 1, 16. 8 divided 32, I have 4. 4 times 1, that is 4. Then 32 divided 32 is 1. 1 times 1, we have 1. So add all the numerators. We have 5 whole number. You can now take away the plus because you are adding this guy to this fraction. You will now have 5 whole number. Add here. This is 21. 21 over 32. So we have succeeded to convert this decimal number to a number in base 10. So let's put our base 10. All right. So I'll solve the second one now, then pick any other two and solve and leave enough questions for you to practice. Okay, to solve this one, we expand first. 3 times 8 plus 4 times 8 plus, because I have decimal, let me demarcate it. 5 times 8 plus 2 times 8. Then assign your indices to this side first. 0, 1. Then for this part, minus 1, minus 2. Now, 8 raised to the power 1 is still 8. 8 times 3, we have 24. 8 power 0 is 1. 1 times 4, we have 4. Then over here, 8 inverse means 1 over 8. Now, 1 over 8 times 5 will give us what? 5 over 8. Look at what it looks like. 8 inverse means 1 over 8. You multiply it against 5. So the whole number multiplies the numerator. 5 times 1, you have 5 at the top. So that is how we'll be performing for every other one. Okay. Then over here, 8 inverse 2 means 8 raised to the power 2, 64. Because we have negative, it becomes 1 over what? 64. Then multiply it against 2. So we multiply 1, we have 2 over 64. Then we can divide. Divide here 1, divide here 32. I divided the both parts with 2. So that means we'll have 1 over 32. So add the whole numbers. 24 plus 4 will give us 28. Plus, let's add the fractions. So we use common denominator, which is 32. You can always use the highest number. The highest number will always be your LCM. That is when you are solving number base. The highest number on highest denominator will always be your LCM. So 8 divided 32 will give me 4. 4 times 5, 20. 32 divided by 32 is 1. 1 times 1, we have 1. So let's add here. We have 28 whole number. Add there, we have 21. 21 over 32. And that becomes the solution in base 10. In base 10. Okay. So let me now do another one. This case will have letters. Let's also see how we perform that, their decimal expression. So expand first. We have 3 times 16 plus d. Use the value of d, which is 13. 13 times 16 plus f is 15. 15 times 16 plus, let me show the difference between this part and this part. 2 times 16. And lastly, b is 11. 11 times 16. So let's assign the exponents. Here is 0, 1, and what? 2. Then when you get to the decimal part, you begin with -1, -2, and so on. So 16 raised to the power of 2 give us 256. Then 256 times 3, that gives us 768. 16 power 1 is 16. Then 16 times 13, we have 208. 15 times, okay, 16 power 0 is 1 times 15. We have 15. Plus here, we will have 2 over 16. We already know how to get it. 16 inverse is 1 over 16 times 2. you have 2 over 16. So divide 1, divide 8. So this will give us 1 over 8 plus 16 inverse 2 means 16 squared. 16 squared is 256, right? Then multiply it against 11. You have 11 over 256. So let's add the whole number parts. 768 plus 208 plus 15. This will give us 991 plus. Then for the fraction, take the highest one as your common denominator, 256. Now 8 divide 256. That is 32. 32 times 1 is 32. 256 divide 256 is 1. 1 times 11, we have 11. So the next thing we do is to add. We have 991, remove the plus, then add here, you have 43. 43 over 256. So we have also succeeded to change it to base 10, all right? Let me solve one more. I will leave the rest for you as assignments and practice questions. So let me pick number I. So let's solve I. We expand. 5 times 16 plus E is 14. 14 times 16 plus B is 11. 11 times 16 plus A is 10. 10 times 16 plus 3 times 16 plus our F is 15. 15 times 16. Assign indices 0, 1, 2, and 3. Then for this part, we have -1, -2. So let's simplify. 16 raised to the power of 3. That is 4096 times 5. We have 2480. 16 squared is 256 times 14. Then we have 3584. Then 16 power 116 times 11. 176. 16 power 0 is 1. 1 times 10, that is 10. Plus here, 16 inverse is 1 over 16 times 3. You have 3 over 16. Then for here, 16 squared inverse is 1 over 256 times 15. We have 15 over 256. Then let us add accordingly. The whole number part first. So 2480 plus 3584 plus 176 plus 10. So we have 24250 plus. Then adding the fraction, we are taking 256 as our what? The common denominator. So let's operate. 16 divide 256 will give us 16. 16 times 3, we have 48. This divide this is 1 times 15, we have 15. So we add. We now have 24250 whole number, 63 over 256, and that is in base 10. Okay, thank you so much for watching. I want to believe you have understood the concept. In my subsequent video or in the next video, we will be looking at conversion from one base to another base other than 10. Okay, we consider conversion of base 2 to base 5 or to base 8, from base 8 back to base 2. Then after that, we also consider conversion from base 10 to other bases. I think that should be the next concept before the initial. So meet you in my next video. Please do well to like this video, share it to your friends, and follow for more interesting math tutorial. Don't forget to subscribe to my YouTube channel. Thank you so much. Bye.